regulators. We regulate any stealing of his property. We're damn good, too. But you can't be any geek off the street. Gotta be handy with the steel, if you know what I mean. Earn your keep. Regulators! Mount up.
Bristol! Oh, goodness me. One day I'm going to stop doing this talk, and I'm going to be way less nervous, because the whole thing is written in JavaScript. And full disclosure, anything can go wrong at any time. Okay? Hey, Bristol. Hi. My name's Ruth. I'm from the UK. I'm from the southwest. I'm from near these towns called Bristol and Bath. So this is kind of really cool because I get to talk in Bristol. This is amazing. I haven't travelled very far. I haven't got off of a flight. This is so good. And I see so many familiar faces in the audience as well. It is actually a pleasure to speak here. Thank you so much for inviting me, Oliver. So yes, my name's Ruth. This is the part of the talk where everybody tells you who they are and what they do and why they get to stand on a stage and tell you about all this stuff. You just saw it. So I'm going to go through and just talk about that, right? I am here to talk to you about how to be a web AV artist. What? Yeah. So I struggle with the practicality of this talk quite a lot because web AV artist doesn't really make a lot of sense. AV stands for audio visualization. That's what you just saw. It's visualizations with audio. Doesn't really belong on the web, right? You're not going to go back into work on Monday morning and just code some audio visualizations into your website, although I dare you to. So I do struggle with the practicality of this talk. I don't know whether you saw this Venn diagram. It did come out a couple of years ago, but I took this very literally. On the left-hand side is what people talk about in conference talks, and on the right-hand side is what you should talk about in conference talks. So I have taken this very literally, and I have made two lists to make sure that this talk is useful for you, right? So things that I have to avoid, as per this diagram: analytics, operational excellence, chat ops, and orchestration. I think I can manage that. But I do have to get in duct tape, workarounds, bike shedding, and coffee, right? Okay. Now I've got my talk anxiety out the way, we can learn about web AV. What is an AV artist? AV stands for audio visualization. This is more visualization than it is about audio, really, because it's taking the audio and making visualizations based on the sound, right? So we're going to be doing a little bit more visuals than we are audio, but they're both in there. I have control over volume. I'm just going to turn it down a little bit, this is loud. I quite like the audience that I'm seeing now because I was worried it would be excruciatingly young. Who remembers this?
Winamp. It really whips the
Nice.
llama's ass.
Thank you very much, audience. Sometimes I do that and everybody's like, what? And you're like, damn. For those of you who don't know, this is Winamp. This is a piece of software which you install on your computer, and it plays MP3 files. MP3 files are sound files. They're actual files. You're not streaming them, right? So you have a ton of these files. You put them in this piece of software, and it plays them. It's very lightweight. It's very cool. This is how we used to play music when we first got computers. That's not entirely true, but I remember this. This is how we used to play music. But this wasn't the best bit about Winamp, right? This was the best bit of Winamp. It had a visualization engine. Yeah, see, some people are like, yes, I remember. So you used to play your MP3, and other sound files are available, through Winamp, and you used to fire this up. And this went in time to the music that you were playing. So you'd sort of play music and then sort of watch this. We didn't have Netflix back then. So I'm just going to do that again because it's not looping. Thank you, Winamp. Visualization engine. This... For me, I was doing audio visualizations back then as well. This is sort of at uni, so it's almost 20 years ago. And this must have been the biggest influence of people who were doing it back then, I think. I think I'm okay to say that. Another word for these audio visualization people is VJ, by the way. We describe ourselves as VJ. So if you hear me use that term, I'm just talking about the same thing. Let's see how we go about building this with the technologies that we already know, right? We know web technologies. That's what we're familiar with. So about sort of, I'm sad that that's kind of ended so quickly. I keep wanting to replay it and replay it. about sort of 7 years ago, we started to get some really interesting APIs in the browser that made me stop and think, could I do this audio visualization stuff? Could I do this visualization, like VJ stuff, in a browser environment? It may not have been my smartest moment, but it was fun trying, right? So the first thing that we need to be able to do audio visualizations is audio. We have a web audio API. This came out 2011, 2012, and we can use it to get audio. So the first thing that we need is audio. There's 4 main ways with the web audio API. You can create your own audio. So you can create an oscillator, and this is going to create your own sound. Probably not what we're looking for. We're looking for a sound that other people are playing. You can grab it from the DOM. So if you've got an audio or a video element in your HTML, you can grab the audio source from that. There is a method to do that with the web audio API. You can stream it from your device. So you can stream it via the microphone or the camera. Now, this is quite useful. So you can basically just pipe in the audio that is coming in from your device. That's pretty cool. Or you can just go and get a file. So if you've got a file sitting on a server, you can go and fetch it. You can bring it into the audio API, and you can use that sound. So they're your 4 main ways. So that's great. This is a sound file. Oh. Okay, so that's picking up on the sound file being imported into the audio API. This one, which is my preferred method, is just picking up on my microphone on my device. Right? And this is really good because you don't know what situation you're going to be in. You don't know which DJ you're going to play with or the talk you're going to be doing, right? So picking up on the mic is a really interesting way of doing it because it means that it doesn't matter what ambient sound is around. So that's my preferred method. Now that we've got audio, we need to analyze that audio. I wasn't allowed to talk about analytics. It's okay, we've got a whole talk to go. So we need to be able to analyze this sound to be able to move the visuals in accordance to what the sound is playing. We can do that with the Web Audio API as well. The Web Audio API is kind of really, really big. It's kind of a little bit intimidating. If you do want to talk, research it more, if you are a music file, I'm here, you can talk to me afterwards. There are some really, really good MDN docs and tutorials on MDN about it as well. But there is an analyzer node, which is the thing that I need to be able to analyze the audio. There's lots and lots of these nodes in the Web Audio API. That's how it's all kind of stuck together. So you have the way that you bring in audio as a node, whether that is via a file or via the DOM. The way that you modify it, the way that you can analyze it, you can put filters on it, you can change the volume. These are all nodes as well. And you kind of string them all together. And that's the way the API works. So we have an analyzer node. This is the thing that I want. I've already got my sound source now. I'm going to attach an analyzer node to it to be able to get that data back. So that's what this is doing. And what that returns for us is an array. We can create this array ourselves. We can make it as big or as small as we want. And it's basically giving us the volume, the gain or the amplitude of any sounds going from low sounds to high sounds at any given time. So if you're playing something quite bassy, we'll get numbers here. So these are going to be louder. So we're going to get higher numbers on the low sounds in the array. And if we're playing something quite high, we're going to get numbers up around here in the higher numbers of the array. Right? We'll go into this in a bit more detail in a minute. But that's basically what I'm dealing with. I'm dealing with an array of values, essentially. This is my analysis. And this is what this is really representing. All I've done is I've created an array. I've created an element for each item in that array, and I'm just changing the height based on the number that I'm getting back. That's it. That took me about a year. Okay, it didn't quite take me that long, but I kind of put HTML and CSS, simple. It wasn't actually quite that simple, and I do sort of have this thing about people saying things are simple. But that is what this is doing. I'm getting back this frequency data, and I'm just looping over it and just creating an I element in my HTML and just changing the height of that with CSS. This was one of my first experiments. And this was actually quite tricky back in the day because we didn't have that streaming of the mic the way that we have it now with the Web Audio API. That all came out of sort of doing things like this. So it has become easier, which is nice. The thing is, I did this and I was like, OK, we can do that. What else can we do? I should probably do some experimentation around this concept. And as we all know, if you want to do some experimentation, you need some inspiration. This is Bridget Riley. She's a super cool artist. It says so on the slide. It's true. And she does these huge paintings of shapes. They're really, really big. They're bigger than this screen. And I was like, I really want to make these into visuals. That'd be really cool. So this was my first inspiration of just chucking things at the DOM and making them move, like this. This is actually, weirdly, just a whole bunch of items positioned with Flexbox, and the width is just changing based on that data that I'm getting back. That's it. A little bit janky, but it works, right? For those familiar with CSS, this is the CSS triangle border hack that you can do. You can just use border styling to make a little triangle. And I'm just changing the opacity based on those levels that I'm getting back. So if I shut up, it goes away. Yeah. And then what happened was I was like, OK, I can do this. Maybe I could try some other technologies, which I don't get to try in my day job. Remember, this is a couple of years ago. Transforms, so CSS transforms were quite prominent because I felt like I'm going to be moving stuff around. I probably want to rotate stuff. We're talking about visuals here. I thought, could I take everything that is in the screen, make it a quarter of the screen, and duplicate it around the screen? Do some nice symmetry stuff. Yeah, you can do that. So this is actually just one thing going on here. And I've just written a function to duplicate it and rotate it around. That's it. And I thought, well, if we can do that, can we drop a GIF in? Yep. Thank you, Flickr. There it is. You can drop a GIF in. And so on and so forth. It kind of doesn't stop. Something that was coming out around the time was blend modes and filters in CSS. Filters are very cool. So filters change things like black and white for images. They can blur images. You can do hue rotates. That actually works on video as well, which for a visualization artist is great. You can just drop a video in the DOM and invert it and do all this cool stuff. Blends are different modes when you're layering different DOM elements up. And they actually work on SVGs. So this is a visualization I did for JSConf 2 years ago. We just came back off this year's, which is basically this on steroids. Now I've sort of moved over to SVG, which I'll get to in a minute, but this is all like layered on top with blend modes because they all work with SVG as well. Another really nice thing to try, especially when you're doing this kind of visual stuff. One really prominent thing was custom properties, CSS custom properties, otherwise known as CSS Variables. Now, this meant that I could sort of power my CSS from my JavaScript, which was very cool because I was doing a lot of stuff with the CSS, but I was also kind of hacking it with JavaScript because the data was coming into JavaScript. But this meant that I could actually just pipe it in directly. And this is how I did it. So this is my CSS up here. I've created a custom property called level on the root. I've just arbitrarily called it 1. And I'm just using it to sort of change some properties like width and height so you can make them bigger and smaller. And then where I'm getting my frequency data, where I'm getting these volume values in my JavaScript, I'm readdressing this custom property. So I'm resetting it to the data that I'm getting in. So it's updating my CSS in real time. That's JavaScript all up in your CSS, people. Welcome to Houdini. This is like a couple of years ago before we started on the big suite. So this document element.style set property level is doing that. And I'm just changing that number 1 to something else. So it's doing all of these things, all of them, right? And you might notice, so this is reflecting or rotating around. I'm changing the width and height. I'm doing some custom properties. I've got some blend modes going on here. It started to get quite janky. It didn't really like operating very well. Wasn't allowed to talk about operational excellence. See where this is going. Let's go back to this. This wasn't very good, and actually this is a GIF. This isn't, all the other demos are actually really in these slides, because if I put this within the talk structure, it just breaks. Like, it really cannot cope with all the stuff that's going on. So I was thinking a lot about performance. This is Ben. This is my friend Ben. And this is an extension to sort of rubber duckying. It's not just, I have got this bug. If you can find somebody who you can talk to your weird ideas about, they're your friend, talk to your weird ideas about them. He was extremely helpful. I was doing an interactive installation. I was just talking it over with him. And we were chatting. I wasn't allowed to talk about chat ops. I was talking to Ben. And he made a few good points. He was saying, you're working with a DOM. You're now working with SVGs because SVGs just give me sort of more shapes and more openness, and it's not just sort of squares and eye elements and things like that anymore. You're working with data, so I'm working with the analysis data, and you're doing a lot of maths. Have you thought about using d3.js? D3.js, for those who don't know, is sort of a chart-based library. It does sort of pie charts and bar charts. People are doing incredible stuff with it now. Nadia was here a couple of years ago talking about the stuff that she does with it. But it's a data visualization library, basically. And he was right. I am visualizing data. So I'm not somebody who jumps on board libraries too quickly, especially when I'm doing personal projects like this, because it's a learning experience. So if somebody says to me, there's a library for that, I'll be like, I'm going to write it, which I'm not saying is a great idea, by the way, but it is good for learning. So this is what D3 gives us. So I did start a whole bunch of experiments around D3 because it did actually help improve performance. This is a book called Super Graphic by Tim Leung. And it's really, really nice. It's just kind of data visualizations of comics and graphic novels, and you can just flick through it if you're into it. It's all just really, really beautiful book just to flick through. So I was flicking through this, and I'll wait for the photo. And I thought this is really good inspiration for my D3 set of visualizations. And these then started. So this is just a sunburst chart, basically, and it's just. I go quiet and then I go loud. You can see how that would work pretty well with music. There's things like the concentric circles you can do just really, really easily. This is reimagining that spectrum that we saw at the beginning of the talk. I'm just using circles on a diagonal instead of up and down squares. And things like flowers. So we're starting to work in circles now. So there's a lot more trig going on, but D3 kind of makes it easy. It really does. And the SVGs look a lot cleaner and prettier, and yeah, it works better. D3 is actually doing the same thing that I was doing before, which is creating a shape per item of the array. So I'm taking that analysis array that I had, chucking it through D3, and D3 is like, yeah, I'm going to create an item per shape. This is fine, but I wasn't satisfied with this, purely because of the analysis that the Web Audio API does. Now, it's still doing the analysis well. It's still doing this, what we call fast Fourier transform on my sound. That means that it's picking out all the frequencies that I want, but it's not doing it in a way that I think creates good visualizations. Bear with me. So this is our array. The low sounds at the bottom are 0 hertz. That's very, very, very low. That's probably the lowest that you could hear if you could hear it that low. The sounds at the top of the array, this is what we're actually analyzing here, are 20,000 kilohertz. Now, your ear can hear that, but in reality, for the most part, it actually doesn't. So there's not a lot of activity here. I'll show you here. This is a keyboard. I'm sure we've all seen a musical keyboard, not your computer keyboard. It sits on this frequency chart around here. So music that we listen to every day, it's not going to go up here. You'll be like, it could, but it's probably not. And actually, if you look at the numbers coming out of an array like this whole top half usually comes out at 0, just because there's no activity. So I don't need this data. It's nice that it's there, but I don't need it. I want this data, right? The other thing about this data is it doesn't really represent music. This is our keyboard. I've highlighted 3 notes on this keyboard. They're all of note A. They're different octaves. So what that means is that they all harmonize really, really well together. One's lower, one's in the middle, one's higher. Right? I'm pretty sure we've all played on keyboards and you understand this. This middle key here, this runs at 440 hertz. Right? So on that spectrum, we've still got our hertz. This one's 440. This one above it is 880 hertz. That's a gap of 440 hertz. Cool. Bear in mind that these gaps here are equal. We would assume that that's 440 hertz lower, but it's not. That's 220 hertz, that low key. So that's a 220 hertz gap. So these gaps are actually getting bigger, even though the note gaps are not. The frequency gaps are. This isn't represented in the array that I'm getting back from the Web Audio API, which is fine for what we need it for. But when I'm visualizing audio, I kind of want it to be a little bit more even. So I want to compensate for what's going on here. So slice off this bit of the data, don't need it, and spread the rest of the data out. Simple. That took a long time. I haven't actually looked at this for about 2 years, and I'm like, yeah, we could definitely refactor that now. But I'm not going to walk you through it, but that is basically what that is trying to do, which processing-wise is interesting. I've got a before and after. So this is a before, right? You can see, I don't know whether this is loud for you, but it's loud for me. You can see how there's a lot of activity around here. So this is the bottom of that array that we saw, right? This is where all the numbers are, and there's nothing going on up here, right? This is after I've done all that work. Everything's a little bit more even. We're getting more of a representation of the fact that this song is higher, right? I think that makes a better visual. Just letting the photos happen. It doesn't even stop there. I just wanted to bring that in because it's after lunch and I thought I'd make you think. At the moment, I was still working with SVGs. And actually, when you start chucking about 100 shapes, like 100 SVGs at a DOM, it doesn't like that either. So I very quickly changed over to a 2D canvas. I've been doing some work around a 3D canvas, which is the visualization you saw at the top of this talk. This is actually a 2D canvas, and I'm just drawing these shapes. It's exactly the same sort of thing. I don't use D3 anymore. I have actually built my own system to do this. And this means I can just chuck however many there are on there. And this isn't running at 60 frames per second, it's running at about 25, but for the purposes of displaying this in the club, I think it's pretty good. I mean, this is a browser. I haven't pulled anything off the main thread yet either. Okay, so we've got visuals. That's great. But as a VJ, when you are actually doing this, you need a way to control your visuals. Now, on our computers, we have keyboards. I could just punch in a couple of keystrokes and get each visual to change when I pressed a different key. That's fine. I did some experiments with the gamepad API. There's a gamepad API in the browser, so taking a gamepad and just seeing if that would work to sort of change up the visuals. But it's a little bit flaky. All gamepads are different, so there's nothing. It was just a bit hard. I settled on Midi. Now, I know you're thinking, Midi, just quick rundown. It's not that bleepy sounds that you think it is. Midi is a data protocol, right? Thank you. The keyboard we saw, this is a MIDI-enabled instrument. So this is a MIDI instrument. It has onboard audio. When you play it, it plays you sounds. But most keyboards these days come with MIDI capabilities. If I plug this into my computer, it's going to send it MIDI signals, which is just data. It's just, I am a keyboard and I'm playing this note. Some instruments have velocity, so I'm playing this note this hard, right? This came about in the late 70s, early 80s, because they had a rise of electronic instruments, synthesizers, drum machines, all that kind of stuff. And they would take them into recording studios, and then they had no way to talk to each other. They literally had all these instruments with no way to orchestrate with each other, right? Wasn't allowed to talk about orchestration. Oh, it's all right, and I've got time. So this is a MIDI instrument. You can also get MIDI controllers. So these send MIDI signals, but they don't have any onboard audio. They're a little bit more affordable, right? You've probably seen one of these. This is a launchpad that I have on screen now. And these are far more common when you're working with a computer because they are more affordable, they're more lightweight. You can use your computer for the audio. That's kind of the idea. You press a button, you make the computer make the sound. No, not me. We have a web MIDI API. So in the browser, just like we have a web audio API, we have a web MIDI API. And this basically picks up on any MIDI signals that are coming into the browser, right? Don't do live demos. This is my handbag MIDI controller. This is a Minim. They all are very similar. You usually get something different sizes. They will have buttons on. They'll probably have dials on. And you can just run this code. Make sure your browser is listening to this. We'll see whether this is working in a minute. And I can press buttons, and I can change those visuals. And I can change different parts of the visuals as well. The system that I have running now, you can change things like the colors, you can do inverting, you can do all those effects on your actual MIDI controller. So with any luck, this is still connected. Yeah. So I have a little mixer down the side. This is a continuous controller. So normally this would be a dial, but because I've got this special little Bluetooth controller, it's just a little slider down here. And then you can set up the buttons. Yeah, I've got a little bit of inverting. Nice. Okay, I don't want to sort of flash everyone. But you get the idea, right? And then you can set these up however you want. And it's almost part of the build, to be honest. this real, or is this just a game? This is very odd. I'm building a piece of what should be OS-level software with a bunch of JavaScript in the browser, with a bunch of sort of APIs that people are thinking, why do we have this? Why do we have like MIDI in a browser? I get asked this question actually a lot, because this is also, I do this, I do code, I make websites. How do you do this? How do you get into this? What is this? This is really what we're cruxing on when we talk about digital art, right? Otherwise known as creative coding. This is it. I sort of came up with an idea, I did some experimentation. This has sort of now become a thing. And web is not the only place where this is really, really prominent, and this is becoming more and more popular. Every single popular coding language has some sort of creative coding environment, right? So C++, you've got Cinder and open frameworks. Java's got processing. You've probably heard of that one. That's probably one of the most popular. That's what most of the artists use. Ruby has got Zajal and Sonic Pi. Zajal is new. It came out last year. I haven't had a chance to look at it yet. But you can see a sort of consistent thing going on here. We on the web, my favorite thing, is we have this browser, which comes with a whole bunch of stuff without having to install anything. Right? We've got those APIs. There's so many more APIs. It got mentioned, we've got ambient light, we've got accelerometers, we've got geolocation just out of that box. That's pretty cool. There are JavaScript libraries. There's things like P5.js, you've got 3.js, there's Tone.js for audio, which are amazing and should be used, but they are built all on top of this technology, this web technology that we have. So to me, like, the other extension to this is when you're doing this sort of creative coding or this digital art, you're looking for data as well. I'm looking for audio data. A lot of artists use data from you as a human, or data calls like weather data or Twitter data or things like that, all still so easily done in the browser. So, is this real or is this just a game? This is a project that I made here. I took this audio visualization software, made it into a little pack. So I have my laptop, my MIDI controller, this tiny little pocket projector, and put it underneath this little pack, and sort of walked around it with an usherette tray. This is actually me projecting onto the streets of Bristol a couple of years ago. So this is with the actual pack, just in a browser with a laptop. I wrote an article about it, and after I wrote in the article, a couple of people came back to me and said, "We're doing this too." I was like, okay, I'm not the only one. And what happened past that is we got together and we started doing this stuff together, because that's what you do in the creative scene. You find like-minded people and you share ideas and you do this stuff together. So, as Phil mentioned, we have Live.js. It's a collective. There's an extra member now. There's musicians, so there's people who build music software in the browser with JavaScript. There are lighting artists. There are people that are controlling massive lighting rigs just by this whole MIDI thing and turning it into DMX, which is what lighting uses. And of course, visualization artists and hardware as well. You can do NeoPixel type, like wearable things and all the rest of it. So that's what we do every so often when we get together, and we share ideas and we do it. We play gigs. Or this whole stage is just running off web technology. This is great. We have a GitHub organization, so it's got to be real, right? There is also a Slack channel. If you go on our website and you are interested in this, please join our Slack channel, because we talk about this sort of stuff. I'm running a little bit early, but I don't think it matters, because I think we're running a little bit late. There is one more thing that I do have to address, obviously. I'm sure you're aware, and the keen-eyed among you might have noticed. Wow. It's all right. This whole thing is held together with duct tape, right? Ben is on a bike. This whole function's a workaround. And I am drinking coffee. Thank you very much.